Hey, hi, Rajan this side. Welcome to the channel. So we have started a 100-question DSA series to crack any coding interview. And in this series, we will cover each and every data structure and algorithm such as array, matrix, string, stack, skew, dequeue, linked list, graph, heap, dynamic programming, greedy, hashing, and bit manipulation. And in this series, we will cover each and every possible questions that could probably be asked in an interview, right? So we have started with array first. So in array, we have already discussed the first problem, that was trapping rainwater problem. And in this series, we will discuss today the second problem, which is container with most water. So in this problem, we are given an array where each element represents the height of the vertical lines drawn on the x-axis. So these are the heights and these are drawn on the x-axis, and this element of the array represents the height. For example, here in this test case 1862, so 1 means the height of the first bar is just 1, and the second height is 8, the third height is 6, and so on, right? And the distance between the two lines is equals to the difference between the indices. For example, let's say I'm taking this and this heights, right? So the distance between these two heights are the difference between the indices. So 6 minus 1 is 5, so 5 is the distance between these two heights, right? Now our task is to find two lines that together forms a container that holds the maximum water, right? So we have to find out two heights such that the water contained in between them is maximum. For example, here in this test case, the most optimal way to choose two height is choose index 1 height and index 8 height, right? So here if you see the water contained here is so this is a rectangle, so we can easily calculate the area. So the area is length into width. So here the height is 7 into the width is also 8 minus 1 7. So 49 is the area, so 49 is the area of the water that is trapped in between these two heights, right? And this is the max possible water that could be trapped in between two vertical heights, right? So to solve this problem, we will start with the brute force approach. So whenever any question is asked in interview, so always start with the brute force approach and then try to optimize it. So we will start brute force. In brute force approach, what we can do, we can pick any two heights and we can try to check if the water content in between them is maximum or not. For example, so in the brute force, what we will do, we will take two heights. Let's say the index are I and j, right? And to get the indices of I and j, what we can do, we can easily use two for loops. So for int I equals to 0, I less than n, right? I plus plus. So this will be the first, the left height, and similarly inside of it we can use another loop to get the second height. So we will start with I plus 1 because it doesn't make sense to have two heights on the same index, right? So start with the next index. So j less than n, j plus plus, right? J plus plus. So this way you will get two heights, and we can easily calculate the water contained in between them. So water that is contained in between these two heights is the minimum of these two heights. See, the reason why I'm taking the minimum of these two heights is because otherwise it will spill over, right? So let's say here if you see the height of the left bar is 8, right? But the height of the right bar is here 7. See, the water that is trapped is only up to height 7, otherwise it will spill over, right? So the maximum water that could be trapped up to height minimum of these two. So the height is a minimum of h of I. So h of I is the height of ith bar, h of j into the distance between them, and we know the distance between them is the difference between the indices. So the distance between these two height is j minus I. So this is the water contained in between them, and let's say I have a global variable that would contain the maximum water, or let's say I'm calling it max mx water, right? So we can initialize with 0. Then we can easily update mx water is equal to maximum of mx water comma this current water, right? So yeah, this is the brute force approach. The complexity for this approach is order of n square because we are using two for loops. But we can optimize this problem to order of n. So we can optimize this from order of n square to order of n using two pointer. Let's see how. So in the two pointer approach, what we will do, so as the name suggests, two pointers means you would be having two pointers, right? So let's see how we can optimize this using two pointer approach. So in two pointer, as the name suggests, we will be having two pointer, right? So one would be the left pointer and one would be the right pointer. So let's say this is the left pointer and this is the right pointer, right? So initially the left pointer would start from 0 and the right will start from index n minus 1, right? So the height at the left index is h of left, right? H of left, and the height at the right index is h of right, right? So we will first calculate what is the water content in between these two indices. So we know what is the water content. So water content is minimum of the minimum. The formula is going to be same, no difference. Left, height of left comma height of right. So the water that could be contained is only up to this height into the distance between these two indices, right? So the distance between these two heights is right minus left, right minus left. So this is fine, and we can similarly update our maximum, your mx water. We will start with 0. So similarly your mx water is maximum of your mx water, right? Previous water comma this current water. This is fine. These two formula is not going to be changed as compared to the brute force approach. The main the main point to understand in this approach is in two pointer, how do we strategically move these two pointers. So either try to move either left pointer or right pointer. So let's consider first case. Let's consider case when your h of left is less than h of right. See, your left height is less than the right height. So let's take example. Let's say your left height is 4 and the right height is 6. See, the water that is trapped here is this water, right? The minimum of these two into distance. Let's say the distance between these two is 2. So the water content is 4 into 2, 8, right? So 8 is the water content in between these two heights. Now try to think which pointer should be moved in order to get the most optimal result in the next step. So regardless of whether you are moving the left pointer or the right pointer, your total distance is going to be decrement by 1, right? So here what we are planning to do, we are planning to either move the left pointer to it one step forward or moving the right pointer to one step backward, right? So regardless of whether you are moving left or right, your total distance is going to be decrement by 1, right? So we know that to get the water, we know we should be having the index and the height, the minimum height. See, always notice the minimum height among these two. So distance is constant, right? So regardless of whether you are moving left or right, the distance is going to be decrement by 1. So isn't it better to get the maximum height in the next step? So if you think of moving the right pointer, it doesn't help because the area here is limited by the minimum height among these two, and moving the larger height doesn't help. It will never ever help, right? So we can also understand from example. So let's say, so in this test case, we have height 4 and 6, right? So let's say in between there are two more heights. Here the height here is again, let's say 6, and the height here is, let's say 2, right? So this is my L, this is my right. So let's consider we are moving the right pointer, right? So in the next step, your L will be same, right would be pointing to here. So this is R dash. See, the minimum here is 2, but if you would have moved the left pointer, then you would have left at here L dash and R. See, the minimum of these two height is 6, right? See, you are getting the maximum height. So this proves that it will always be optimal to move the left pointer. The left pointer in the sense ki always move the pointer that has the minimum height, because your area is limited by the minimum height. So I hope you understand this problem. So in this approach, let's say you started with two pointer, left pointer and right pointer. So initially left would start from 0, right would start from n minus 1, and we will check if the left height is less than right height or the right height is less than the left height. So whichever is the smaller height, try to move that pointer, because the area is limited by the minimum height, right? And if you move the maximum height, it will never ever help you. So here, the first case, if your h of l is less than h of r, l plus plus, else r minus minus, right? So yeah, this is all about the explanation part using two pointers. So the complexity for this approach is order of n, because we are having two pointers left and right, and in every step we are moving like either one of them, either left pointer or a right pointer, based on the height, right? So yeah, let's look at the code now. Here is the code. So we are given the height array. So first we will fetch how many heights are there, right? And then as discussed in the explanation, we will start with the two pointer approach. So in two pointer we have left pointer and the right pointer. So initially left pointer would start from 0 and the right pointer would start from n minus 1, right? The first and the last index. And this is the maximum water that could be contained in any of the two heights, right? Then we start with the while loop. So while left pointer is less than the right pointer, we will first try to find what is the water content in between this left and right, right? So the water content is, we know the water content will be the minimum of these two heights, height left, height right, into the distance between these two heights, and the distance between these two heights is the difference between the indices. So the difference between the indices is right minus left. Now we will update our maximum water. So maximum water is equal to max of max water, comma this current water, this water content, right? And now so this is the most beautiful part in this approach. We know that the area is limited by the shorter one, right? The shorter one would limit the area, so it will always be optimal to move that one. Otherwise, if you're moving the taller one, that would never ever help you. So that's why what I have done here, I have just checked if the left height is less than the right height, then move the left pointer, otherwise move the right pointer, and keep on doing this process. So this is the most optimal approach. So the complexity here is order of n, because we are having one while loop, and where you have two pointers, and in every step you are either moving the left pointer or the right pointer, right? So your length is decrement by one in every step. So this loop would last only for n number of times, right? And at the end return your max water. And one more thing I would like to mention here, always try to have the meaningful name to each and every variable, because that shows the positive point to the interviewer that you are following this practice from your learning itself, right? Because if you work in a company, you always have to follow this convention that always try to have a meaningful name to the variable. So please start following this approach from your journey itself, because that shows a positive point from you, like, so to the interviewer. So yeah, this is all about the code. If you find the video helpful, please like, share and subscribe to my channel.